Atherosclerosis is a disease process that affects medium and large-sized arteries in the body, where cholesterol begins to build up in the wall, kind of like rust on a copper pipe or rust on a pipe. And as it builds up, it attracts blood cells into it, so it becomes inflamed, the artery becomes inflamed, and eventually the artery narrows so there's less blood flow to the organs, and it also triggers a blood clot which can abruptly close off the artery and trigger a heart attack, stroke, or sudden death. So it's a very common disease that affects human populations all across the globe.
Does the food or sedentary influences in arteriosclerosis?
Yes, lifestyle is a very important determinant of risk. We know that if you're sedentary, if you eat a lot of saturated and trans fats, or you smoke and don't exercise, or have a family history of premature heart disease, or have diabetes or high blood pressure, all of these factors increase the risk of atherosclerosis and the complications of atherosclerosis.
What can you tell me about the vaccine that you are working on?
There are a number of ways to reduce the risk of atherosclerosis, and one potential target for atherosclerosis is the LDL cholesterol, which is the type of cholesterol that gets deposited in the arteries. And once it's deposited, it causes inflammation by activating the immune system. So in essence, atherosclerosis is an autoimmune disease where your body's immune system is reacting against antigens derived from your bad cholesterol or the LDL cholesterol. So the idea of a vaccine is to suppress this autoimmune response. So it's a different type of a vaccine compared to a vaccine against infectious disease. For an infectious disease vaccine, you try to activate the immune system. For atherosclerosis, you try to downgrade the immune system so that it doesn't react to autoantigens. And that's the concept we have been testing in the laboratory for nearly 20 years or longer. And we're now at a stage where we've shown that vaccine made from small protein fragments of the LDL cholesterol reduce the buildup of atherosclerotic plaque in animal models, reduce inflammation, and we're gearing up to test this idea in humans probably within the next year or 2 years' time.
Can you tell me a little bit about the history of your research?
Yeah, it was back in 1994 when my laboratory and that of a Swedish collaborator, Jan Nilsson's laboratory, began to speculate that perhaps it might be possible to suppress the immune system to prevent autoimmunity, which accelerates atherosclerosis. And we were not sure whether this idea would work or not, so we started first experiments in rabbits using LDL taken from one group of rabbits and given as a vaccine to another group of rabbits. And to our shocking surprise, we noted in the first experiment 70% less atherosclerosis in the immunized rabbits compared to unimmunized rabbits. We didn't believe it first. We thought it was probably a fluke. So we retested in another animal model and got similar results. And then we were certain that there's something to it. Then it took many years of very laborious hard work to map the antigens within the LDL cholesterol and identify those antigens that, when used as a vaccine, would provoke a protective immune response. And we have a candidate antigen which we call P210, peptide fragment, that we have shown that when you use it as a vaccine given subcutaneously or through the nose, we suppress autoimmunity and inflammation in the arteries, and there's much less atherosclerosis. This is all in animal models. We haven't tested the idea yet in humans. That's where we are.
How long do you think it will be available for you?
I think once we start human testing, which would be within a year to 2 years, it's another 3 to 5 years of testing process in humans. And if it works as we think it should, then it could be 5 years or so, 5 to 7 years from now. that we could have potentially a vaccine in the market. We have to get lucky as well, because everything that works in the animal model doesn't necessarily work in humans. So we have to prove that it works in human models as well.
Does the arteriosclerosis can cause some thrombosis?
Yes, one of the major mechanisms by which atherosclerosis triggers a heart attack or sudden death is that the surface of the plaque breaks loose and a blood clot abruptly forms, and that clot closes up the artery, and that's how sudden heart attack or sudden death can occur. And if the same thing happens in the arteries of the brain, you can get a sudden stroke. So blood clot plays a very, very important role in the complications of atherosclerosis.
Does the female hormones can cause some thrombosis?
When female hormones are used as supplements or as birth control pills, there is clear evidence that they increase the risk of blood clotting and pulmonary embolism, venous thrombosis, and heart attack and stroke. And this is particularly true if you have a genetic tendency to form blood clots due to mutations in certain genes. Then the estrogen replacement can actually markedly increase the risk of blood clotting. So in certain individuals, the answer is estrogens can stimulate blood clot formation.
What else can you tell me about atherosclerosis?
The best way we know how to prevent atherosclerosis is to really focus on nutrition and exercise, but from childhood onwards. If we can maintain a low level of cholesterol from childhood and through most of the life, we can significantly reduce the risk of atherosclerosis development. So lifestyle is a key factor for prevention of this disease. Avoiding not smoking, eating a healthy diet, and regular exercise. Of course, genetics plays a very important role, but we can't choose our parents, so it's not within our control to modify the genetics, but the lifestyle certainly plays a very important role.
How often do you find people that produces the cholesterol, even they are active and eat well?
Yeah, there are many examples of genetic defects that cause you to synthesize cholesterol no matter what you eat. And there are different severities of these genetic defects. One type of genetic defect, which we call as heterozygous FH, or familial hypercholesterolemia, occurs in 1 out of every 250 to 500 cases. And the more severe form of this, called homozygous FH, occurs in 1 out of 1,000,000. And in certain populations, the frequency is even more. For example, French Canadians, Afrikaners, they have a much higher risk of this genetic form of hypercholesterolemia.